Hey, welcome everyone. This is my first video of the week, and it is the essential questions for this week are um, from module 6.3, Vertex Form versus Standard Form. So we're going to get into Vertex versus Standard. How do we use these forms to graph a quadratic function? And how do I go from Vertex Form to Standard Form? And later on during the week, we're going to get into 7.1, which we dive into the axis of symmetry and how do I find the vertex in an equation in standard form, and how do I just graph, right, from standard form. So just a little bit of review. Here are your slides for the review. Remember that the axis of symmetry is the vertical line that passes through the vertex of your parabola. Okay, that vertex is that red point down there. And it's always going to be x equals the h, which is the x value of your vertex. Okay. This is the standard form of a quadratic. This should be reviewed as well. So y equals ax squared plus bx plus c. Notice that we have our x and y values here. And to find the axis of symmetry, it's just x equals negative b over 2a. So these two equations you guys do have to know. So please write them down in your notes. And we're going to just somewhat use these two forms, these two formulas, or this form and this formula for the axis of symmetry to figure out what the axis of symmetry is. So my next slide is the vertex form. Remember, vertex form is a little bit different. It's where your h and your k appears, right? G of x equals a times x minus h quantity squared plus k. A, remember, is your vertical stretch or compress, depending on what your a value is. And h comma k is the vertex of the parabola. So it's very essential that you guys think of transformations when looking at vertex form. So the rest of the video is on just some examples, okay? Here is your first example on 6.3. So it says to determine whether the function represented by each equation is a quadratic. Remember that a quadratic only appears when you have x squared, okay? So a quadratic means that there is an x squared somewhere in the equation. There's an x squared. So it's very simple. I see an x squared. It's pretty valid that everything is simplified, everything is good, so that x squared will still be there. So yes, it is a quadratic, okay? This one, if you simplify this, I'm going to subtract x. I'm going to gather the like terms, right? 2y equals, what is that? 13x plus 6. And then if you divide it by 2, you can also divide it by 2. Okay, remember, if you divide it by 2, the dividing by 2 goes to every term. So y equals 13 over 2x plus 3. Right? And this one, since there's no x squared, there's no x squared to start off here as well. But you can see that there is no x squared. So this is a no. Okay, so we must have an x squared in order to be a quadratic. Okay, so the next set of examples is right here. Rewrite the quadratic function from vertex form. Remember, vertex form is like this, to standard form, the ax squared plus bx plus c. Here, right, we're just gonna multiply this out. So y equals 2. Now, since this is squared, right, x plus 5 quantity squared, I am just going to make them x plus 5 times x plus 5 plus 3. This 3 just follows down here. And if I FOIL this out, or if I multiply this out, we did this in our previous module, right? X times X is X squared. X times 5 is plus 5X. 5 times X is plus 5X. And then the last, plus 25 plus 3 times 2 equals Y. Make sure that you guys do close out the parentheses after you guys multiply. Okay, we need these two parentheses here because we're going to multiply the 2 out before we do anything with this 3. Okay, so if I simplify what's inside by gathering the like terms, I see 2 5x's. So it's 2 times x squared plus 10x plus 25 plus 3 equals y, right? And then I'm going to proceed by distributing out this 2. So it's 2x squared plus 20x plus 2 times 25 is 50 plus 3. So y equals 2x squared plus 20x plus 53. And that is my standard form. Okay? So another example would be on another page here. Okay? So, and here I'm going to highlight a special form that we went over. Okay? This, you can factor it out just the same way, right? X minus 7 times x minus 7, and FOIL first is x times x, which is x squared. Outside, which is x times negative 7, which is negative 7x. Inside, I'm just spelling out FOIL if you guys are confused. Negative 7 times x is negative 7x. And then last, negative 7 times negative 7 is plus 49. If you gather the like terms, that's x squared minus 14x plus 49. Or you can use the special form, which I'm going to do here. Okay, this math and what I'm going to do is the same thing. So just choose one and just go with it. It's going to be x squared. You're going to square the first term. You're going to go minus, because this is a minus, 2 times x times 7 plus 7 squared. Okay, the special form that I used is a plus b quantity squared, or a minus b quantity squared equals a squared minus 2ab plus b squared. This one is going to be broken down into a squared plus 2ab plus b squared. Okay, so that broken down, and then the plus 2 would just follow me down here. So y equals negative 3 times x minus 2 times 7 is 14x plus 49. Notice plus 2. Notice that I get the same thing, x squared, that I got up here. Okay, so this math here and what I just did is the same thing. All right, I just gave you guys 2 ways to do the same thing. Now I'm going to distribute out the negative 3. Distribute that out. So negative 3x squared, negative 3 times negative 14, that's positive 42x plus, or no, minus, because negative times a positive is a negative, 147, right? Negative 3 times 49. And then the plus 2 equals y, and then y equals, just gathering the like terms and cleaning this up, minus 145. Okay, so that is my standard form of that one. All right, and really quick, my last, use each table to write a quadratic function in vertex form, then rewrite the function in standard form. So here the vertex is that. Remember, the vertex form is y equals a times x minus h, quantity squared, plus k, right? So I can essentially just plug this in for h comma k because this is my h comma k. My vertex is h comma k. Okay, so y equals a times x minus -2, that's plus 2, quantity squared, plus k plus -7. I should have just put -7, but it is what it is. And then I got to figure out what a is. But I have a bunch of x and y values here. I'm going to use that first one because that's a 0. Okay, so -27 is my y value. 0 is my x value. So -27 equals a times 0 plus 2 quantity squared minus 7. Okay? So that's -27 equals 2 squared, or you know what? A times 2 squared minus 7. 2 squared is 4a minus 7 equals -27. All right? And then I'm going to go ahead and proceed to just solve for a. So I'm going to add 7 to both sides. Add 7 to both sides. And then I have -20 equals 4a. Divide by 4, divide by 4. So a equals -5. Right? If a is -5, I'm going to plug it back into here. So y equals -5 times x plus 2 quantity squared minus 7. That is my vertex form. Okay? And then here, from here, you got to turn it into a standard form, which we already did. All right, so that's 6.3 in a nutshell. Please do your delta math along with your bookwork. All right, thank you. See you guys next time.